You know the feeling. You spend weeks, maybe even months, architecting this beautiful AI system.
Oh, yeah.
You've got the prompts engineered to absolute perfection. You've connected all the tools. You've set up the vector database, and you finally deploy it.
It feels good.
Yeah.
It's not just a chatbot anymore.
No, it's an agent. It has agency. And you give it a complex request, something like plan a marketing strategy for Q3, research the top 3 competitors, and draft the initial outreach emails.
The big one. The one you built it for.
Exactly. You hit enter.
Yeah.
And just silence.
The spinning wheel of death.
The spinning
The
wheel.
universal symbol of I'm thinking, but I might also be, completely broken.
Exactly. Or, and this is almost worse, it comes back 3 minutes later and says, I have successfully booked a table for 2 at a pizza place in Naples, Italy.
Yeah.
And you're just sitting there thinking, I live in Ohio, I asked for a marketing strategy, and I don't even like pizza.
The classic total misalignment. The agent just went completely off the rails.
Yeah.
It's the nightmare scenario for anyone building these things.
Right. And here's the thing. In the old days, if my Python script failed, I knew exactly where to look. I'd check the logs. I'd find a syntax error on line 42, maybe a missing semicolon.
A variable you forgot to define, yeah.
Something simple. But this feels different. It feels like the machine just, I don't know, changed its mind. It feels like it made a choice, and it was the wrong choice.
That's because it's not a syntax error. It's a semantic error.
Yeah.
It's a logic error in a system that is, well, by definition, non-deterministic.
Right.
We aren't really debugging code anymore. We're debugging a chain of thought. We're debugging its decision-making.
And that is the terrifying part. Because if you can't see the thought process, you can't fix it. You're just guessing.
You're just poking a black box with a stick, hoping it behaves better next time.
Oh, I'm blind.
You're flying blind. And that is exactly what we are unpacking today. We are doing a deep dive into that very black box of agentic AI.
Specifically, we're looking at the monitoring stack, the tools, and I guess the philosophies that let you tear open that black box and actually see the gears turning inside.
Yeah, how to get some visibility.
We have a massive stack of documentation here, research notes, implementation guides. We're going to cover what the source material calls the core triad of monitoring.
Which is request tracing, quality evaluation, and the SRE signals.
And we are going to get into the weeds on the specific tools that the industry is kind of rallying around. LangSmith, LangFuse, and the big one, OpenTelemetry.
And just to be clear, we aren't just talking about high-level concepts today. We're going to talk about which environment variables you need to export today to stop your agent from, hallucinating or
burning through your credit card.
Or burning through your credit card with infinite loops. That's a big one.
I want to start with the problem itself, though, because I think a lot of developers, especially if they are coming from, say, traditional web development, they underestimate this.
Oh, absolutely.
They think, I have logs, I have console.log, I have print. Why isn't that enough?
It's a fair question. In a traditional app, let's say a web shop, request A leads to response B. It's linear.
Click buy.
User clicks buy, server processes the payment, server says success. You can log the input and the output, and you're pretty much done. But an agent is a loop.
It iterates, it talks to itself.
Exactly. You give it a goal, it thinks, it decides to use a tool, let's say a calculator. It gets a result, that result changes its next thought.
Then it decides to search Google.
Right. Then it summarizes that search. Then it realizes the search wasn't good enough, so it changes the query and searches again.
It's a conversation.
It's a conversation with itself, and it's all happening at lightning speed. And if all you have are flat logs, like a text file full of standard print statements, all you see is a jumbled mess.
A total mess.
You just see search tool accessed, followed by calculation complete, followed by error. You lose the causal chain.
You don't know why it decided to search Google. Did the calculator fail? Did the prompt just confuse it?
You see the error, but you completely, totally miss the why.
And that's the whole ballgame.
Precisely. And that brings us to the first pillar of our core triad, request tracing. The source material calls this the spine of observability.
That's the perfect metaphor. It really is. If logs are just a pile of disconnected bronze, then tracing is the skeleton that holds them all together in the right shape.
It preserves the relationship between events.
The causality.
Yes. Instead of just seeing output, you see the entire family tree of that output. You see the initial prompt. Then you see the span. That's the technical term for the model's thought process. Then nested inside that, you see a span for the tool call.
Ah, so it's hierarchical.
Exactly. Then a span for the retrieval step. It's all connected.
It sounds like having a CCTV camera inside the agent's brain.
That's a great way to put it. It's about debugging behavior, not just code. You can replay the tape.
Okay.
You can look at a trace and say, okay, at step 3, the agent correctly identified that it needed flight data, called the flight API. The API returned the correct data.
So far, so good.
But then, at step 4, the LLM looked at that data and just hallucinated a completely different price.
And that distinction is crucial. I mean, from the user's perspective, the bot just lied about the price.
Right. To
Uh,
them, it's just broken.
But as a developer, you have to know, was it the API that gave bad data, or was it the LLM, the brain, that misread the data?
Exactly. Because one of those is a back-end engineering fix. Maybe the API is broken. The other is a prompt engineering fix. Maybe the model needs better instructions on how to read the JSON it gets back.
Without tracing, you're just guessing which one to fix.
You might spend days fixing the API when the API was perfectly fine the whole time. It's a waste of time and effort.
So that's tracing. That's the spine. Okay, the second pillar you mentioned is quality evaluation.
Right. So tracing tells you what happened. Evaluation tells you if what happened was actually any good.
And this can be tricky, right? I mean, good is so subjective.
It is. Massively. In traditional software, good usually means didn't crash or returned to 200 OK status. It's
Sure.
binary.
Yeah, it worked or it didn't.
But in AI, good means,
Yes.
well, it means was helpful, was
Mhm.
not toxic, was accurate, didn't sound like a pirate unless I specifically asked it to.
Right. Don't be a pirate unless prompted. A good life rule.
It is. And you can run these evaluations online in real time, or you could do them offline, running a battery of test questions against your agent to see if its performance is drifting over time.
Okay, we'll definitely get deeper into that later, especially with how tools like LangSmith handle it. So what's the third pillar?
The third pillar is production SRE signals. SRE stands for Site Reliability Engineering.
Okay, so this is the nuts and bolts.
This is the nuts and bolts. This is the boring stuff.
The vital stuff.
The vital stuff, the stuff that keeps you employed. We're talking about latency. How long did the user have to wait for an answer? Error rates. How often does it just completely crash? And maybe most importantly for AI, cost.
Token usage. The silent killer.
Token usage. Because unlike a normal database query, which
Mm.
costs, fractions of a penny, a GPT-4 loop that gets stuck repeating itself can rack up a bill of hundreds, even thousands of dollars in an hour if you aren't watching.
I've seen the horror stories on Twitter of people waking up to a $5,000 OpenAI bill because their agent got into an argument with itself about whether a tomato is a fruit or a vegetable.
It happens way more than you'd think. SRE signals are your early warning system for that kind of disaster.
Right.
They answer questions like, why is this request suddenly taking 45 seconds? Or why did our API bill double yesterday? You need all three, tracing, eval, and SRE, to actually trust an agent in production.
Okay, so let's recap the analogy. Tracing is the X-ray, the MRI.
Yep.
Evaluation is the doctor's diagnosis. Is it good or bad? And SRE signals are the hospital bill and the heart monitor.
That's a very grim but surprisingly accurate analogy. Yeah.
Let's talk about the tools then, because concepts are great, but we need to know what to actually pip install. The research highlights three main paths: LangSmith, Langfuse, and OpenTelemetry. Let's start with LangSmith.
Okay, so LangSmith is the ecosystem play. It's built by the same team that's behind LangChain.
Which, for anyone who doesn't know, is basically the default framework for building agents in Python and JavaScript right now, or at least one of the biggest.
It's certainly one of the biggest, yes.
Yeah.
So if you are already using LangChain, if you're using their prompt templates, their retrievers, their chains, all that stuff, LangSmith is designed to just slot right in.
It's the Apple ecosystem approach.
Exactly. It just works.
The documentation describes the setup as low friction. I always get a little skeptical when I hear low friction.
You too.
Usually that means easy to start, but impossible to customize later. But let's look at the setup. What does it actually involve?
It's surprisingly lightweight. It starts with environment variables, those hidden settings on your server or your local machine.
Right, the stuff you put in your .env file and hope you don't commit to Git.
Exactly.
Yeah.
And the magic switch, according to the docs, is export LangSmith tracing true.
That's it. Just set it to true.
That's what activates the global tracing. Then, obviously, you need to authenticate, so you export your LangSmith app
Of
again.
course.
And this is a pro tip from the source material, and it's a big one. You should really, really set a LangSmith project variable.
Okay, why is the project variable so important? What does that do?
Well, imagine you're testing a new prompt. You run it 50 times, trying to get it right.
Right, lots of trial and error.
If you don't name your project, All those 50 messy, broken test runs get dumped into the default bucket right alongside your real live production data.
Ah, so you're polluting your own data.
Total data pollution. Suddenly, your production dashboard shows a 50% error rate, and you have a minor heart attack. But it's not real. It's just you messing around on your laptop.
So you need to keep them separate.
You have to.
Yeah.
Set LangSmith Project Dev Sandbox or something similar. It's basic hygiene.
Okay, so I've set the variables. Am I done? Do I need to go and rewrite all my code?
Not necessarily. The source outlines two main ways to do this. The first is what they call the wrapper method. This is specifically if you are using the OpenAI SDK directly without all the line chain framework stuff.
So if I'm just calling client OpenAI in my code.
Exactly that. You can install the LangSmith SDK pip, install -u LangSmith OpenAI, and then you just wrap your client. The code literally looks like this. Client, wrapapino, OpenAI.
That is incredibly lazy. I love it.
It's fantastic for getting started.
Yeah.
By making that one little change, every single time that client makes a call to GPT-4, it automatically logs the prompt, the completion, the latency, and the token count straight to LangSmith.
But here's the rub. We talked about agents. Agents do more than just call GPT-4. They have logic. They have loops. They use tools. Does the wrapper capture any of that?
No. And that's the big limitation. The wrapper only sees the LLM call itself.
The final step.
Right. It doesn't see the why. It doesn't see your Python code deciding which prompt to send in the first place. It doesn't see the database retrieval that happened before the prompt was even built.
So if I want the full MRI scan, not just a snapshot, I need the second method.
You do. You need the @traceable decorator.
The decorator. Okay, for those not deep in Python, can you explain what a decorator does in this context?
Sure. Think of it like a sticky note you put on top of a function in your code. You import traceable from the LangSmith library.
Okay.
Then, let's say you have a function called runAgentTurn that takes a user message and figures out what to do. You just write @traceable on the line right above that function definition.
And what does that do to the trace when I look at it in the UI?
It creates what's called a parent span. When you look at the visualization in LangSmith, runAgentTurn becomes this big horizontal bar. And everything that happens inside that function, the database lookup, the math calculation, and the API call, becomes a smaller bar nested neatly inside it.
So I can see the hierarchy. I can see that runAgentTurn took 5 seconds total. And then I can see that, 4.9 of those seconds were spent inside the search database child span.
Exactly. It instantly isolates the bottleneck.
Yeah.
You aren't blaming the AI model for being slow if you can clearly see the database is the thing that's taking forever.
That's incredibly powerful. And the visual aspect seems to be a huge selling point for LangSmith. The whole UI is designed to look like a tree of thought.
It is. And it's interactive, which is key.
Yeah.
You can click on any node in that tree, say, the retrieval step, and see exactly what documents were found. You can see the raw text chunks that were fed to the model.
So if the bot gives a wrong answer, I can click the retrieval step and see, oh, it pulled up the policy document from 2019, not the updated one from 2024.
Right. And you know immediately, I need to update my vector store, not I need to spend hours prompt engineering the model. It points you to the real source of the problem.
That saves you hours of just tweaking prompts in the dark.
Wasted time. Yeah.
Okay, so LangSmith is the integrated visual choice, especially for LangChain users. But not everyone wants to be tied into that ecosystem. And more importantly, not everyone can just send their data to a third-party cloud.
And that brings us to our second tool, LangFuse.
LangFuse. The name implies fluxing things together. I'm not sure.
I think so. But the key differentiator here, the headline, is that it is open source and it's heavily focused on self-hosting.
Okay. Why is self-hosting such a big deal in this space?
Well, think about what you're sending to these agents. It's not just what's the weather. It's customer data. It's financial queries. It's proprietary code. It could be medical information.
Summarize this patient's history and recommend a diagnosis.
Right. You absolutely do not want that flying off to some random startup's cloud server, no matter how secure they claim to be.
There are compliance issues, privacy issues.
All of it. So LangFuse allows you to spin up their entire monitoring stack using Docker on your own infrastructure. You keep all the data. It never, ever leaves your virtual private cloud.
And looking at the configuration notes here, that's handled by the LangFuse host environment variable.
Yes, that's the switch. If you use their cloud, it points to cloud.langfuse.com. But if you self-host, you just point that variable to localhost or your internal server IP address.
That's a huge win for any company dealing with sensitive data. So beyond the hosting, does LangFuse think about the problem differently? Or is it just an open source clone of LangSmith?
It has a slightly different mental model, which I think is really interesting. LangFuse is very, very focused on the concept of sessions.
We touched on this earlier, the idea of an entire conversation, not just one turn.
Exactly. LangFuse makes a clear distinction between a trace and a session. A trace is one execution. I press enter, the bot replies. That's a trace.
One round trip.
But a session is the whole interaction. It's hello, hi, book a flight, which airline, Delta. All that is one session.
And why is grouping by session so critical for debugging these systems?
Because of the context window. As a conversation gets longer and longer, the entire history gets stuffed back into the prompt for the next turn.
Right, to remember what you were talking about.
And eventually, you might hit a token limit. Or the history might get so noisy and contradictory that the model just gets confused.
Ah, so the bug might not even be in the current request. The bug might be that 3 turns ago, I said something that completely polluted the context for everything that came after.
Exactly. If you only look at the single trace, you see.
Hmm.
User said, yes. Bot said, error. That makes no sense at all. But if you look at the whole session, you see the previous question was, are you ready to delete the entire production database?
Context matters a lot.
Context is everything. LangFuse's UI is built around replaying that entire session timeline. You can see how the context window grew with each turn, how the latency changed over the course of the chat.
That seems incredibly useful for things like customer support bots, where conversations can go on for dozens of turns.
It's essential. You need to see if the performance degrades over time. Does the bot get stupider the longer you talk to it?
I think I know some people like that.
We all do. But we definitely don't want our software to behave that way.
So implementation-wise, is it a similar setup to LangSmith?
Very similar. It's pip install LangFuse. You have your LangFuse public key and LangFuse secret key that you need to set. The core philosophy is the same. Stop guessing, start tracing. They have decorators and wrappers too, though the syntax is obviously a little different.
I noticed in the notes for LangFuse, they also emphasize the term observations. Is that different from a span?
It's just their term for a span or an event within a trace. It's actually a nice naming convention because it implies you are, well, observing the agent's behavior. It helps distinguish the trace, which is the whole, from the observation, which is the part.
Got it. Okay, so we have LangSmith for the deep ecosystem integration, and we have LangFuse for the open source, self-hosted, session-focused approach. But then there's the big one, the one the enterprise architects always bring up.
OpenTelemetry, or OTel if you want to sound like you've been to a few conferences.
OTel isn't really an AI tool, is it? It's a much more general software tool.
That's correct. It is the industry standard for distributed tracing. It's a CNCF project. It's vendor neutral. It's supported by Google, Microsoft, Amazon, basically everyone.
So why would you use a general purpose tool for a very specific problem like AI monitoring?
Because your AI agent doesn't live in a vacuum. It lives in a stack.
A messy, complicated, sprawling stack.
A very messy stack. Imagine you are a large bank. You have a mobile app. When the user asks a question in the chat, that request hits a load balancer, then an authentication service, then a routing service, then it finally gets to the AI agent.
And then the agent probably calls a mainframe database.
And the AI agent processes the result, and it all goes back out through the same chain.
That is a lot of hops.
It's a ton of hops. Now, if you use a tool like LangSmith, you only see the AI part. You see request received by agent and answer sent from agent. But what if the latency, the slowness, is actually happening in the authentication service before it even reaches your AI?
You'd be debugging your prompt for hours, wondering why it's so slow, and you'd be completely unaware that the login server is on fire somewhere else.
Exactly. OpenTelemetry allows you to trace a single request across the entire system. It creates a single trace ID that gets passed from the mobile app to the backend to the AI and back again.
So in my visualization tool, I can see the AI span right next to the SQL query span, right next to the HTTP request span.
Yes. And usually, you're visualizing this data in standard observability backends like Jaeger or Tempo, or the most common one, Grafana.
Grafana. I feel like every engineering office I've ever visited has a giant TD screen on the wall with a Grafana dashboard on it just showing wiggly lines.
It's the cockpit of the SRE team, and that's the real appeal here. If your DevOps team is already staring at Grafana all day to monitor CPU usage and server memory, they don't want to open a separate website like LangSmith just to see what the AI is doing.
The single pane of glass.
The dreaded single pane of glass. Managers love that phrase. But in this case, it's actually true. OpenTelemetry lets you treat the AI agent as just another microservice in your architecture.
But there has to be a downside, right? It can't be all sunshine and vendor-neutral standard.
The downside is the setup time and the complexity.
Yeah.
LangSmith. You toggle an environment variable, OpenTelemetry. You are writing YAML configuration files. You are setting up collectors and exporters. You are defining your own span processors. It is not low friction.
It's high friction, high reward.
That's the perfect way to put it. It's for the power users, the large organizations that need total control and total integration into their existing monitoring stack.
Before we move on to best practices, we have to mention the old reliable that the notes bring up, classic monitoring.
Yes. Good old Prometheus and the ELK stack Elasticsearch, Logstash, Kibana, or Loki for logs.
This feels a bit like bringing a stone axe to a laser fight. Why do we still need standard log files and metrics if we have these fancy detailed traces?
Because tracing, especially for LLMs, can be expensive. Storing every single thought process, every prompt, every completion for every single agent run takes up a lot of storage and can be costly to query.
Sometimes you don't need the whole story.
Sometimes you just want the aggregate numbers. You just want to know, how many total errors did we have in the last hour?
Right. You don't need to read the full transcript of every failed conversation for that. You just need a counter.
And Prometheus is fantastic at counting things and calculating rates.
So you use classic monitoring for alerting.
Exactly. You set a rule in Prometheus. If the P99 latency goes above 10 seconds for more than 5 minutes, page the on-call engineer. You don't want to be manually refreshing the LangSmith dashboard at 3 a.m. to catch an outage.
You want PagerDuty to scream at you while you're asleep.
I mean, you don't want it to, but it's necessary. And that's what classic monitoring is for. It complements tracing. It's not an alternative. It's a crucial partner.
Okay, so to use another analogy, classic monitoring is the smoke alarm. Tracing is the forensic investigation team that comes in after.
That is a perfect analogy. You need both. You need the alarm to wake you up, and you need the investigation kit to figure out who started the fire.
Let's move to production hygiene. We've picked our tool. Let's say we went with LangFuse because we're privacy conscious and we want to self-host. We've installed the SDK, but the notes here have a big, bold warning about the "it works on my machine" problem.
This is the most common pitfall, the absolute classic. You develop the agent in a Jupyter notebook, it works perfectly. You're a genius, you deploy it to the cloud, it breaks.
Or it just acts weirdly.
And you can't figure out why, because the environment is totally different. The data is all mixed up.
Right.
Both LangSmith and Langfuse, all the sources, they really emphasize environment management. You need to explicitly, programmatically separate dev, staging, and production.
We mentioned the LangSmith project variable earlier. This is exactly where you use it, right?
Yes. Your laptop should export project, agent v1 dev. The staging server exports project, agent v1 stage, and the production server exports project, agent v1 prod.
It sounds so obvious when you say it, but I guarantee people skip this step.
They do, all the time. And then they try to calculate their average latency for the week, and the number is completely skewed because a developer left the debugger running on their local machine, so half the requests in the dataset took 10 minutes to complete.
That just ruins all your analytics. You can't trust the numbers anymore.
Completely. You're looking at a graph that tells you nothing because it's mixing apples, oranges, and, hand grenades.
Now, the expert notes here say that the single most important part of debugging is not the trace itself, but actually the metadata you attach to it.
I cannot stress this enough. If you take nothing else away from this whole deep dive, tag everything.
What specifically should we be tagging? The source list gives us a few key ones: agent version, model name, tool name, and customer ID.
Let's break down why each of those is critical. Imagine you deploy a new version of your agent. Let's call it version 1.2. Suddenly, users are complaining it's slower or dumber.
Okay, a regression.
A classic regression. If you don't have a tag for version, you're just looking at a big bucket of mixed traces. You can't easily tell which ones came from the new code and which came from the old code. You can't compare them head to head.
You can't do a proper A/B test without tags.
Exactly. Or take model name. OpenAI, Anthropic, Google, they update their models behind the scenes all the time. Or maybe you decided to switch from GPT-4 to the cheaper GPT-4 Turbo to save some money.
And suddenly the quality of the answers just tanks.
Right. If you aren't tagging all your traces with model GPT-4 Turbo, you might spend a week thinking your code is broken, when actually the underlying model just got worse at that specific task you're giving it. You need to be able to filter by model to prove it.
And what about customer ID? That one seems really important.
That's the forensic one. That's the one that saves you from pulling your hair out. Let's say you see a massive spike in latency at 2:00 p.m. Just a huge wall of slow requests on your dashboard.
Panic mode sets in.
Total panic.
Yeah.
But if you have customer ID tags on every trace, you can filter by customer. And you might realize, wait a minute, this isn't a system-wide outage. This is just customer X.
And then you can drill down and look at what customer X is doing.
And you see they are uploading a 500-page PDF of dense legal gibberish and asking the agent to summarize it every 30 seconds, over and over again.
So it's not a bug, it's a user behavior issue, an abuse pattern maybe.
Exactly. Without the tag, you're rewriting your back-end code to fix a performance issue that doesn't exist. With the tag, you're just emailing the customer to say, hey, could you please stop doing that?
That turns a system-wide mystery into a customer support ticket.
It saves countless hours of engineering time. It's metadata. It's the boring part, but it's absolute magic for debugging.
This connects back to quality evaluation as well, right? We touched on it earlier, but tagging lets you slice the data for quality checks. You can ask, is the summarized tool working better for our premium users than our free users?
Right. Or does the agent perform better on questions about billing versus questions about technical support? You can tag the topic of the conversation too.
Oh, that's really smart. You could use a cheap classifier model to just tag the topic, billing, tech, sales, and then check the error rates and quality scores for each individual topic.
Exactly. You might find that your agent is a genius at sales, but hallucinates wildly whenever it's asked about technical support. You wouldn't know that if you just looked at the global error rate. You'd just see a mediocre number. Tags let you find the specific weak spot to focus your efforts.
So we've covered the philosophy, the tools, and the hygiene. We're coming to the end of our dive here. I want to try and synthesize this for the listener who is sitting at her desk right now, looking at their broken agent and thinking, okay, what do I do right now?
Let's give them a decision matrix, a simple flowchart.
I love it. Step 1, pick a tool.
Okay. If you are living and breathing in the LangChain ecosystem, if your code is already full of LCL chains and chat from templates, just go with LangSmith. It is the path of least resistance. The integration is seamless. You'll be up and running in 10 minutes.
Step 2, the alternative path.
If you are building something open source, or if you work in a regulated industry, healthcare, finance, defense, and you absolutely cannot send data to a third-party SaaS cloud, use LangFuse and self-hosted on Docker. Or if you really care about that session view, if your bot is highly conversational, LangFuse really shines there.
And step 3, the enterprise path.
If you are an architect at a Fortune 500 company and you're building a massive distributed system where the AI is just one small cog in a giant machine, bite the bullet and set up OpenTelemetry. It's more work up front, but your SRE team will thank you because they can see everything in one place.
And regardless of which of those 3 tools you pick.
Regardless of the tool, export your environment variables, separate your dev and prod data, and for goodness sake, tag your traces with metadata.
And watch your costs.
Please, please watch your costs. Set an alert for token usage. Do not let the robot bankrupt you. It's a real risk.
I want to leave our listeners with a final thought. We kind of touched on this in the very beginning, this idea that we aren't really debugging code anymore.
It's a fundamental shift in what we do as developers.
When you look at a trace in LangSmith or LangFuse, you see the agent thinking. You can see it consider using a tool, then reject it, then try another one, fail, loop back, reprompt itself, and try again. It feels, I don't know, almost biological.
It does. We're moving from the realm of pure computer science to something more like AI psychology.
Right. We aren't asking, where is the syntax error on line 52? We're asking, why did you intend to do that? What was your reasoning?
And that raises this massive, thorny question for the future. How do we debug values? If the trace shows the agent technically followed all the instructions, but the outcome was manipulative or biased or just plain creepy, that's not a bug in the code.
It's an alignment failure.
It's an alignment failure. It's a personality flaw in the software.
And right now, these monitoring tools, being able to see the thought process, are the only window we have into that personality. We are, in a very real sense, watching the ghost in the machine.
And as the models get smarter and the chains get longer and the agents become more and more autonomous, that ghost is going to get a lot harder to track.
So you better start tracing now.
You really better.
On that slightly chilling note, that is it for this deep dive on agentic AI monitoring. Go set LangSmith tracing true.
And check your OpenAI bill.
We'll see you next time.